Hi, good morning. Welcome back to Mike Makes It. Bit of an assortment of bits and pieces on the bench today. And the plan is I want to make a tester for these pneumatic actuators. Pneumatic actuator in this case is you put an air supply into the device here, and depending on which one of these particular solenoids you have engaged will force this arm in or out. Same principle applies for this. Depending on where you put the air supply or gas supply into the actuator will force the arms in and out. There's a multitude of different ones, sizes, etc. you can get. This is like a medium size one compared to the others I have here. But largely we use the smaller ones at work. So I'm gearing up the tester to test these. That's an actuator that will turn the air supply on and off to these devices. This one in particular hasn't actually got any switching capabilities, purely gas or air in or out on there. It relies on this sort of component to switch the air on and off. So as I said, I'm making a tester for one of these. We can repair these on the bench, but unless you take it to the machine, you can't. There's no way of testing it. So hence that's where the idea has come up for a tester. Now, move a few bits out the way. Basically, I planned one out on a breadboard using two NE555 timers. The whole concept of the tester is 9-volt battery in a box like that. A single push button will actuate a relay which fires the NE555 timer that stays on for a predetermined time, and while that's on it powers up the second NE555 timer that'll give a function to a relay to either actuate or not the unit under test. The idea is you're going to be able to manually trigger this, or through the use of the NE555 have a variable pot on it to allow it to clonk on and off up to 5 times a second. So you'll be able to run a little short diagnostic test on it. So that's the plan. I've been working on it for a little bit. There's the breadboard layout, and that does work okay. So we moved over to veroboard, which I've used for a long time. Because printed circuit boards to etch them at home, I've made a few, probably half a dozen in my lifetime, and it's fine. It just takes a long time to do. Veroboard was a quick and cheap way of doing it. It's okay. It's not as neat as it could possibly be, but I've made probably hundreds of projects on veroboard, all successful. But with the advent of companies, and I'm not sponsored by them, most people seem to be, JLCPCB. There's other manufacturers in China that make printed circuit boards, but I found a program called EASY EDA, which is a schematic diagram creation tool on it, and that'll link straight over to, I don't know if it's a parent company, but somehow EASY EDA and JLCPCB are linked. Basically, you create a schematic, then move it over to a PCB layout, have a little tinker on that, make sure you're happy with it, then you can send the file straight to JLCPCB. That's what I did, and for the cost of, I believe, £1.51 plus about £3 shipping, they've sent me 5 printed circuit boards. Oh yeah, and a cat mobile phone stand, which I shall be using actually, so that's alright. I've opened the bag. It's come, I won't say hermetically sealed, but it's got a little silica gel bag in there. Make sure you don't eat them. Always says do not eat, so do not eat. Open the bag up. There's my printed circuit boards. Ridiculous price. Even with the postage, they would have worked out £1 each. For me to make one of those at home, ferric chloride, etch them, I've got to drill them, I can't tin them, I can't put the silk screen on them. As long as you're not on a time constraint, these took about 2 weeks to ship to my house after I created the file, the Gerber file, and sent it to him. Basically, within 12 hours, this had gone into production in China. So very, very happy. I had a couple of emails from them. They had a query on something, and I replied within an hour. They replied within an hour back to me in the middle of the night. Typically, I guess they're about 8 or 9 hours ahead of us, so that wouldn't be uncommon. I suspect their website is 24 hours production, but I'm not sure on that. But it's come back a lovely PCB. I did let the auto router do its bit. I think on hindsight I might do it manually next time. Some of the traces are a little bit close, within the tolerance I expect, but very happy with that. There is another project in the pipeline where I may be able to make a machine that'll actually carve out the traces on a printed circuit board itself. I could mill out the tracks, but that's a later project, but that is underway, so keep a lookout for that. So what I'm going to do today is populate this board. Hopefully the file I sent to him was accurate to my schematic diagram. We're about to find out, I guess. So I'm going to dig up all the components I need and hopefully turn something like this into a working printed circuit board. Sounds there's probably another delivery from Banggood at the front door, so if you excuse me for 2 minutes, I'll build this and answer the door. Okay, I think I'm ready to proceed to assemble the board, so that's what I'll go ahead and do. Well, that's the printed circuit board complete. I like putting the resistors the same way round, colour code wise, just for neatness, not that you'll generally ever see this again. Going to clean the back of the board up, get the flux off it. Big bit in the middle is a buck boost converter. That'll take the 9-volt battery supply up to 24 volts, which feeds the actuator. The actuators we use at work are 24 volt powered, so we need to boost it up a little bit. The two NE555 timers, the two relays that I'm needed, and other is just a little bit of timing circuitry for the timers. The connectors will go off to this little wiring loom I've made up earlier. A couple of indicators for when the actuator is supposed to be switched. A couple of push button switches to operate the box correctly. I can show you that the full function of that when it's actually all up together. Another little switch there. Now I've made the PCB so it'll fit into the lid of the box. Got some mounting holes there, so that'll pop in there. You'll have a 9-volt battery in a clip. I've got a 9-volt battery clip that'll sit on the side. That'll go on the top, and the switches, LEDs, indicators, etc. They'll be mounted on the lid here, or on the base of the box, depending on which way you look at it. So that's what I'll do now. I'm going to go in the garage, I'll mark a few holes out, and we'll pop the holes in for the controls. Right, I figured you've watched me drill holes before, so I haven't videoed this, but there's the box drilled out. Turn it round. This is going to be the single shot on off switch. Press it once, the device switches on. There's going to be a single shot switch there to actuate the actuator, which will make sense when you can see it running, and there's going to be another switch that switches on the variable action, i.e. it'll switch on and off up to 5 times a second on its own, or the single shot option. A couple of holes for LEDs, hole in the back end there, let the cables out to the actuator, and in the other end this is going to be fitted. That's a variable speed control for it. So yeah, I'm going to put all that together, drop the cables in, cable loom's ready to go in, that feeds the actuator. The other cable loom is here that you've seen earlier, so I'll put them all in the boxes and run the cables to the correct length, terminate them, and you should see a near completed actuator tester. So that's the plan. I'll crack on with that and I'll come back to you. Right, here we are back in the garage. I've terminated all the cables to a reasonable length, crimped them all up, fitted it all together. There's the inside of the box, and it actually works, which I'm quite pleased about. Spent a lot of time on it. And the end result is we'll be able to test one of these. In this case, it's a small pneumatic actuator. This piston will move in and out depending on which one of these solenoids is actuated. So we go back to the tester. This one here is the on button. This is single shot, and this will switch between the single shot test and the variable speed test. It's got about a 20-second timer on it. Press on. You see those lights flashing. Probably can hear a little noise. Well, there's the actuator going. It'll time out in a second. When it does, I'll switch it back on and alter the frequency of the test. There you go. That's with the pot on the end. If we want to go to single shot mode, like that, switch it back on, press this button, and you can do that. So you can leave it, well, you can't leave it running because it's only timed for 20 seconds, but it'll certainly give you a reasonable test time. If not, just press the on button again. Well, that was what it was all about. Actuator tester. I'll put the lid on it, take it to work. Job's a good one. Like I say, there's in the middle there's a 24-volt buck converter. Well, it's a variable output actually. I'm sticking 9 volts into it, adjusted the pot, getting 24 volts out, because these actual actuators there are 24 volts, so hence 24. But I'll put all the files up online on the old Google Drive, schematics and PCB layout if you're interested. But if you found the actual video interesting and enjoyed it, please give me a thumbs up and subscribe to the channel. Thanks very much.